All right, here we go. First thing is this zero, the last zero. It has to be the product of 5 and an even digit. And that 5 can go in one of two places. We don't know which one it's going to go in, but for the time being, let's try it there. Now, since this number that is 5 times a 3-digit number is still 3 digits, the first of those digits must be 1. Since this is 100 something times a digit, then some more digits must be ones. I guess this digit over here has to be a 1 also. There's no way those things can add up to 200,000. All right. Now, since this 1 and this digit and whatever this adds up to carry, then this digit has to be at least an 8. I'm gonna Is there something weird about this? So apparently these things aren't pure white, so I can't flood fill the boxes to make them obvious to you. Anyway. That one. That one has to be at least an 8. So that means that the second digit after the 1 at the top has to be at least a 6. Now, actually, that's not quite enough, because if this is 162, no, if this is, what the heck number would that be? Yeah, 162, and this would be 810. The next number above it could be is 15. And yeah, 81, 15, and 1 is 98. That's not quite enough. If we make so what is enough? 164, 820, and 15 is still not enough. Oh, actually, we know more than this. Yes. So Math Grant has pointed out in the chat that, well, maybe not exactly what he was thinking, but because squares aren't 0, this second box down here has to be at least a 1. And since there's no way you can make it be more than a 1, we'll make it be exactly a 1. That means that our squared box has to be a 9. And then we have a carry from the other column. So now we have to have at least 1/8 something in the top row. And maybe 1/9 in order to get a carry. Well, no. If this is 1/8 something, and this is 1/7 in this row, from 1/8 something multiplied by 9, then we have 18. We need this to be at least a 3 in order to avoid a 0 at the bottom. So we need to have at least 186 at the top. Oh, there's some more things I can fill in, actually. We know these zeros can't sum to a 0 because it says squares aren't 0. And we can only possibly have one carry. So we have a 1 there. We're starting to get to the point where we can just say, well, what multiple of one of these numbers has this pattern? But let's try to solve it for real. Oh, we have another. Yes, Grant is pointing out the possibilities of filling in these first two partial products. These other two digits in the 5 here have to be at least 6, since they're larger than the 900 something at the bottom. And 6 times 186 is already more than 1100. So we can't do it. So this means that my initial assumption that the 5 goes there was wrong. And that's why we have the undo key. So the 5 has to go over here. And we have to do this the hard way. Well, maybe it's not the hard way. Maybe it'll actually be easier this way. Because now we know these other two partial products are going to end in 5s. We can bring a 5 down here. We still have a 1 in a couple of places. Here. Here. Yes, this product ends. The first partial product ends with a 6, 5, 7, 5, 8, 5, or 9, 5, which gives us too many possibilities to kind of sort through at this point. Now, we know this first digit is even, so it's at least 2, and 2 times this first number gives us something that's still 3 digits. So, we know the first digit of this product is a 4 or less. And let's see. All right. Um, this is tough. Oh, Grant has solved the combinations that end in '05. Given that we know um, we have an odd digit times some digit and 5. If we had 5 times some digit and 5, it wouldn't work out because we'd always end up with 2-5 or 7-5 at the end. If we had a 1, we just repeat the same 2 digits and we can't have a 0. If we have a 3, we get 15, and then we need to have another 3 to make a 9 to give this 0. If we have a 7, we have 35, and we need a 1 to make a 7 to make the 0. And if we have 9, we have 45, and we need a 4 to make 36 to give the 0. So, I suppose I'll just start plugging in these possibilities and seeing what happens. So we're going with the 3 and the 3 because it's the smallest of the numbers, and it seems like worth trying first. Oh, I put that in the wrong place. It's supposed to be a 3 here and a 3 here. Now, if it is a 3, we need the digit before it has to be smaller, since it makes a 3-digit product and the other one makes a 4. That means that we have to have a 1 in this first box. And we filled in the whole... oh no, not a 1. We need to have a 1 in this first box. And therefore we have to have a 3 or 4 in the first box, but a 3 would give us only 1,005. It needs to be more than that, so it has to be a 4. So 1305. The bottom row is 870. Does this look like something that's going to work out? This digit will copy down here, whatever it is, and we'll carry 1, and we'll get 8, 9, 10, and we'll get a 0 here where we're not allowed it. So, no. Not 3, 3. So let's try, the next possibility is a 7 times something ending in 15. Now, in this case, our possibilities are much more wide open. Since the first digit of those numbers can be a lot of things and still work. Well, I think let's try plugging in possibilities for this first number and see what happens. So we got a 4 because I think it's the most restrictive. It might not be, but we'll see. So we can fill in the whole number. That's 2,800 plus our 7 times 15, which is 105. So if we have 29. If we make the first digit of in front of the 7 a 3, no, it has to be an even digit. If we made it a 4, it'd be too big. So it has to be a 2. It's the only possibility. We have 830 at the bottom. And now we have 12 plus whatever this is. We carry 1. So we get a 1 here. And we get 2 more than whatever this digit is at the bottom. Now, we actually have a problem, though. And that is that we can't fill the last digit because 3 times 415 is more than 3 times 415 is 1245. 5 times 415, 5 times 415 works. So maybe we don't have a problem. Let's plug that in. 7 times 415 is the one we already put in there, and 9 is going to be 3,700 and something. But this one's pretty nice. It gives 2075 across the top. This gives us a 2. We have our carry of 1 here. We have 4 here. And I think that all works. All right, let's. So I think we've got a solution, but we should confirm that there's not some other solution. Actually, I backtracked a little too much because I still had more possibilities for the 7. If the first digit is 3, then we get 2205. This digit 4 is again too big, so we have to have a 2 again. And we're going to have trouble because now this is only 630 at the bottom. We can't get our carry. So that's no good. If we put a 2 here, now we have 15. And then we need to have a 4 here in order to have a even vaguely possibly a large enough number. We've got 860 at the bottom. And I think we're going to have trouble with our carry again. So these add up to 101, but we need to have at least 111 down here, and this other number can't make enough. And the first digit here is 115. We can't even make 1,000 in the second partial product. So let's get rid of that. We'll put in the 9, the 4, and some number. Let's put in the 4 again. Like we did last time, run through possibilities. So that's 36, 396, and 45 is 4,005. Well, that's no good. We can't have another 0. So we'll put a 3 up there. And now we're going to end up with 3105. And the next number at the bottom is not going to work. We're going to end up with 2 times this number, 690. And this other number is not going to be big enough to make our required 111 at the bottom. Put a 2 here. This one's a little more promising because now we can put a 4 as the first digit of the other factor. And then we've got 2205, if I've done that math right. Um, 980 at the bottom. And now at least we have a big enough number that this might work. Can we make this 0 work? No, we can't, because 5 times this is 1,200 and something. 7 times it is going to be 7 times is going to be 14 to a 1,700 and something, and 9 times it is the number that's already there. So none of them work for the first partial product with that set. Oops, what was that? Oh, somehow I hit a key that made this go to 10%. All right, I don't know how I did that, but anyway, so what I was trying to do was put a 1 up here, which might make something possible. We get 1305 in the middle product. We get, what number is going to be large enough to make this bottom work without it overflowing? I guess a 6 is the only possibility. 8's clearly too large, and 4 is clearly too small. So we have 600 and 840 and 870. And that's borderline again, because now we need this number to be 11. So that's not going to work. And that was it. That was the last possibility. So we know that the answer that we found is the only one. The answer that I copied on the right. And Google confirms a calculator that 415 times 275 is 114125, confirming that I did my math right. So that's that. I hope you enjoyed the show.